and welcome to a 10-minute topic talk through video, except this might be more than 10 minutes because I've got a lot of stuff to do. This is all the stuff we're going to cover. It's just my notes. So let's get started straight away. It's all about differentiation and stuff relating to differentiation. So we'll start with the easiest stuff. So they've given us a y and it says find the gradient of the curve when x equals 4. So this is a straightforward question. You just need to find dy by dx by timesing by the power and lowering the power by 1. And then because we want it when x equals 4, we just substitute x equals 4 into dy by dx. And that tells us what the gradient of the curve is at that point. And then you just shove that into your calculator and you get a number, and that's your answer. Okay? Next. This time it's kind of backwards. So they've told us the gradient and we want to find the x. Okay, so we're going to do the same thing. Find dy by dx by lowering the power and timesing by the power, like that. We want that to equal 7, and we're going to try and find the x. So we just need to solve this equation, and that's our value of x. If this had been a cubic, then when we differentiated it would have been a quadratic, and we'd have had to solve a quadratic, so there'd be 2 answers, but you know how to solve quadratics. Okay, next type of question. I think this already came up in paper 1, but you know, it says when x is 2, the gradient is 10, work out the value of k. So same method, find dy by dx, like that, and we know that x is 2, so we put x is 2 in there, and it says it equals 10, so we put equals 10, and then we just solve this. So that makes 12k plus k equals 10, so 13k is 10, so k is 10 over 13. Okay. Next, find the equation of a tangent. Okay, so this is going to be the same kind of thing. We find dy by dx, because that gives us the gradient function. Then we need to sub x equals 1 into there to work out what the gradient is at the point when x equals 1. That's going to make 4. So we know it's y equals 4x plus c, because tangent means same gradient. We need to substitute a point in here to work out the plus c. They didn't give us a y, they only gave us an x, so we're going to have to find the y. Make sure you use the y equation for that, not the dy by dx. So I work that out, that gives me 5. So then I can sub 5 equals 4 times 1 plus c. 5 is 4 plus c, so c is 1. So y equals 4x plus 1. Next, finding the equation of a normal. Exactly the same process, but you need to get the perpendicular. So 3x squared minus 8x plus 5. Then we're going to sub x equals 3 into that to work out what the gradient is when x is 3. That's going to make 9, 27, take away 24 plus 5. I apologise in advance for all the arithmetic errors I'm going to make. Okay, but that's the tangent gradient. So we need to negative reciprocal that to get the normal gradient. So y equals minus an 8th x plus c. Again, we need to substitute a point into here. We don't have a point, they only gave us x, so we're going to have to find the y. Sometimes they give you the x and y if they're feeling generous. Okay, and then we work that out. 27 take away 36 plus 15 minus 2. What's that? 42, take away 36 is 8, take away 2 is 6. That's probably wrong, but you get the idea anyway. And who really wants to work that out? 6 take away 3/8, that's 5 and 5/8. The method is what is important here, not the actual numbers. It's calculator paper anyway, so who cares? Next, stationary points. So here's a y, it says find the stationary points and determine the nature. So nature means max, min, or inflection. So first we're going to find the stationary points. Stationary means not moving. So in terms of gradient, it means a 0 gradient. So we need to equal that to 0 to find the stationary points. Oh great, it's a cubic. I love solving cubics. Okay, no, it's okay. I can factorise that out like that. Okay, so x equals 0 or x equals 1. Because it says stationary points, I need the y coordinate as well, so let me just work out what the y's are. So for 0, it's going to be 0, isn't it? And for, what's the other one? 1, it's going to be minus 1. Okay, so I've got 0, 0, and I've got 1 minus 1. Now, to determine their nature, we're going to have to go either side. So if we take x equals 0, we're going to have to go a little bit to the left and a little bit to the right, and we're going to plug that into dy by dx. Like that. And work out what that is. That's going to be negative. We only really care if it's positive or negative. And then this one's going to be negative as well. So because it goes negative, 0, negative, it means it's a point of inflection. And then we do x equals 1. We're going to go a little bit to the left and a little bit to the right and find the gradient. Right, that's going to be negative, and then this one is going to be positive. So because it goes negative, 0, positive, that is a minimum point. So we can say 0, 0 is a point of inflection, and 1 minus 1 is a minimum point. Next, find the range of values for which that is a decreasing function. So we touched on this. I've never seen this in a past paper. I don't know, have you? We did this in class. Find dy by dx, like that. If it's a decreasing function, it means it's kind of generally going down like that. So we need the gradient at all times to be negative. If it was increasing function, I'd be going greater than 0 instead. And then we just solve that the way that we solve inequalities. If it was a quadratic inequality, you'd have to be doing your sandwich and toast kind of thing. But that's it. And, oh my gosh, I actually finished in 8 minutes. I'm so impressed. You're probably not impressed. You're probably like, why did you rush it so much? But you know what? It's YouTube, so you can pause it. And if you were stuck, you can watch it at like 8 times slower speed or something like that. I don't know. Anyway, hope this was helpful. Hope it covered everything you needed it to cover. And let me know if there's any other topics you'd like me to do, but you have to let me know really quickly because your exam's tomorrow and, you know, okay. Anyway, bye.